like to look at another example, and this is going to seem a little bit strange because we'll use a mathematical practice here that may not seem as relevant to you. We're going to look at 3 examples today, and I start with the limit as x goes to infinity of x times sine of x plus 3. Would you guys agree that in our previous examples that involved sine and cosine, the limit did not exist? And so a lot of times people will look at that and they will say, well, the limit doesn't exist because it has sine. That is incorrect. And let me show you what you can do. I'm going to take the limit as x goes to infinity. What should I factor out? I factor out an x, and I get sine of x plus 3. Okay? And sometimes we need to make an argument about what really happens with this piece. So you don't take the sine of x out of that, you take this x right there. See that? So we're going to call at most and at least. I want you guys to think about the sine function. Sine always oscillates between 2 values. What 2 values does it oscillate in between? 1 and -1. Everybody agree that sine is always between the 2 values of 1 and -1? So let's let sine be its biggest value of 1. Suppose sine was 1, then 1 plus 3 is 4 times x, I would have 4x. So at most, it would be 4x. Suppose we had the least value of sine. What is the least value of sine? And -1 plus 3 is 2. So at the very minimal, you have 2x. So if we were to plug in a large number for x and multiply it by 4, we'd come up with another very large number, which would be infinity, right? Let's look at the least option. Suppose you take 2 times a very large number. You're still going to come up with a very large number. So you can see that this argument shows us, yeah, this is smaller, that's bigger, but they're both still headed towards infinity. So in fact, that's the result. Okay? Now, taking out that graphing calculator, go into y equals. And in my graphing calculator, as I turn it on, y equals, clear, clear, and clear. And I'm going to type in this function, 4 minus x over 3x plus 2. Okay, and this is interesting to me because so when I take an AP exam, so I've taken your AP exam before, never forget the first time I took it, I scored like an 87%. And I thought to myself, I might not be qualified to teach this class. Then I visited with other people who took the AP exam. They're like, oh, actually 87% is really good. You shouldn't feel that bad. And I learned that if you get like a 60% on the exam, you get a 5. So after I practiced for a while, I've yet to actually get all the questions right on a multiple choice AP exam. My best is 44 out of 45, but most of the time I get about 42 out of 45. On the free response, out of 54, the best I've done is a 53 out of 54. Most of the time I get about 50 out of 54. It's a tough exam. I make mistakes. In comparison, the ACT, I generally get every problem right all the time. So just note that what you're going to go into is challenging. Now, the problem that I give you today is a problem that I got wrong on the AP exam, okay? And so I'm going to show you a little bit about how that works. What we want to do is part of what we mean by finding these limits as x goes to infinity is that's the same as what we call horizontal asymptote. And as I graph that function, I press zoom 6, you can see the shape that it makes. And this line right here is what we call a horizontal asymptote. As I press trace, I want you guys to look at the y value as the x value goes to infinity. So the x value is tailing off towards negative infinity. Anybody want to guess what the y value is going towards? I'm going to continue to move over and over and over again. Looks like it might head towards 0, right? In fact, it doesn't head towards 0, and I'm going to show you why. It gets close towards 0, but there's another number it gets close to first. And we're going to determine that by doing the following. The limit as x goes towards negative infinity. And the limit as x goes towards positive infinity. You actually know how to do this already because you practiced it yesterday. But when it comes to these asymptotes, you have to make a small change. I want you guys to think, first of all, suppose I plug in a large negative number on the top. What are you going to come up with? What is 4 minus a really large negative number? Everybody agree you're getting a large positive number? And then look at the bottom. 3 times a large negative number plus 2. What are you going to come up with? A large negative number. So does everybody agree that this answer should come out negative? Okay, so we're going to find it. What should I factor out of the top? And when I factor out the x, what do you get here? 4 over x minus 1. And what do you factor out of the bottom? X. And you get 3 plus 2 over x. What's going to happen to the x's? They will cancel. What does 4 over x go to? 0. What does the bottom go to? 0 there. And what are you left with in the top? Negative 1. What are you left with in the bottom? 3. So you can see, Tim said, 0 is negative 1/3 kind of close to 0? It's kind of, but in fact, it is, and we did get the negative 1 that we thought. Question? So as x goes towards infinity, those are going to get really small. 4 divided by a really large number ends up being really small. Yeah, negative infinity, you'll get the same thing. Okay? Right. So let's try the next one. Instead of plugging in a negative number, I'm going to plug in a positive number. What's going to be 4 minus a really large positive number? A negative number divided by 3 times a large negative number. 3 times a large positive number is positive plus 2 is positive. Everybody see it? This is going to be negative as well. So you're going to get the negative 1/3 as well. We don't have to do the same work over. We know what we're going to get. Just know that both of these end up being negative 1/3. Yep.
So if you did the thing that we just did with like the figuring out if it's going to be a large negative number over a large positive number, like how do you know that you're going to get the 1/3?
If we
like if it was opposite, like if it was supposed to be like the top one, the x to negative infinity, like we figured out that it's a negative 1, but then the bottom one, x positive infinity, we figured out it's a positive 1. Like we can still do the work then, or is it going to be positive 1/3?
it will be the positive 1/3. Yep, exactly. And we'll show you that right here. So let's try this one out. And this time I'm actually going to start by plugging in the negative and the positive so we can make the determination right away. Limit as x goes towards negative infinity and limit as x goes towards positive infinity. Okay? So we'll do the work here in a second, but let's start with the positive infinity so everybody can see this. If I square a really large negative number and multiply it by 2 and add 1, what kind of number am I going to get? Yep, and then you take the square root and it's still going to be positive, agreed? And then the bottom, you take 3 times a really large positive number and minus 5, it's still going to be a really large positive number. So in this situation, you can see that this will be, in fact, positive. So it's going to be positive. So I'm just trying to make a determining factor whether it's positive or negative. And then let's do the negative part, okay? So I'm going to plug in a really large negative number. When you square a negative number, it becomes positive times 2. Positive plus 1 is still positive. Square root is positive. Everybody see how even though I plug in a large negative number, I still get positive in the top? Yeah. And then the bottom, 3 times a large negative minus 5 is going to be negative. So do you see that in this situation, it does in fact produce a negative output. Okay, so it's different. In this situation, either way it was a negative 1/3. But in this situation, you're going to get opposite signs. Let's figure out what it is. What can you factor out of the top? I'm going to factor out the x squared and put it there. And I get a 2 plus 1 over x squared. What do we factor out of the bottom? X, and you're left with? Good. Can I bring that x squared out in front of the radical? If I bring it out in front, what does it become? So I'm going to put that there. And what's going to happen to those x's? They will cancel. And then the 1 over x squared and the 5 over x, what happens to those? They both go to 0. So what are you left with in the top? So you get the square root of 2 in the top, and what do you get in the bottom? 3. So notice how my work ahead of time showed that this is going to end up being the negative root of 2 over 3. And in this situation, I get positive root of 2 over 3. So when you consider horizontal asymptotes, you need to look ahead of time at whether you're going to get positive or negative values. Now, I'll be honest, folks, we'll use this a little bit in Chapter 4, but I show you this just because I've seen a couple AP problems on it, and that's one that got me, and I want to make sure that you see it. So they asked for the horizontal asymptotes, and I just wrote this one. That's all I did. I didn't check the other direction at all, and I got it wrong. So got to check both. That's all we have. Your time to work and ask questions. Answer key is posted. Test is when?
Friday.
Next week, Friday. I'm going to do my best. I'm subbing next hour for Miss Jeffrey. I'm going to do my best to make a study guide and have it ready to go by the end of the day because our dear friend, Mr. Easton, is getting his wise teeth removed. Yes. So I'll come around and help you.